If I'm trying to resolve more than one vector using components, I can find ways of comparing them, I can find ways of combining them, and we get a number of different styles of examples of these. These always turn out to be like level 3 type of questions generally. So let's go through a couple of examples to try and get you to realize how to do it. So 2 boys A and B start swimming simultaneously across a dam exactly 50 meters wide. So we've got 50 meters, we've got boy A, we've got boy B. The directions and magnitudes of the average velocities with which they swim are indicated in the diagram. So we've got 3,2 meters per second and we've got 3 meters per second. 3,2 is at 75 degrees, 3 is at 80 degrees. To the bank in both cases. They maintain their respective directions and speed throughout the exercise. You have to do the necessary calculations and say which will reach the opposite side first. How many seconds after the first swimmer reaches the opposite bank will the second one do so? And you have to give your answer to 1/10 of a second. So the first thing I'm going to do is I'm going to resolve both of these vectors into their vertical and horizontal components. Let's work the one in one color and the other one in another color. And of course, the way that I do that is by creating a parallelogram around the diagonal of that particular line. These aren't ideal pictures, but they're good enough. So if I draw out the green picture nicely, I land up with a diagram that looks like that. We have got the horizontal component of A. We have got the vertical component of A. We have 3,2 and we have got 75 degrees. I am now in a position to say sine of 75 degrees. Let's just label this. That would be opposite, this would be adjacent, this will be hypotenuse. So sine of 75 degrees is equal to VA, my opposite, over my hypotenuse 3,2. Plug that into my calculator and I get that VA is equal to 3,1 meters per second. We only need to know how fast they get across the river. So going across the river is important. We don't really care how far down the river they are going to land up. So let's only worry about our vertical component of this velocity. Taking a look at the second diagram, I've got 3,0 and complete the diagram around that. My horizontal of B, my vertical of B, and 80 degrees in this angle over here. Again, labeling my opposite, my adjacent, and my hypotenuse. I can say sine of 80 degrees is equal to the vertical of B divided by 3,0. And when I punch that into my calculator, check that you can do this on your calculator. The vertical of B is going to land up being 2,95 meters per second. Now, they are only making progress across the river at their vertical components. So in other words, across the river, boy A is going faster than boy B. So in terms of answering the questions, which one will reach the opposite bank first? It's going to be boy A is going to get across the river first. How many seconds after the first swimmer reaches the opposite bank will it take the second one to? So now I need to work out the times to get across the river. I know the distance directly across the river. And you can see now how important vectors are in terms of the vertical component, speed, is exactly the same, must be in exactly the same direction as the distance if I am going to do a calculation. So first let me work out the time of A, and the time of A is going to be, if you remember your triangle, I don't need to use equations of motion because I am in a, there's no acceleration, it's all happening at constant velocity. So speed is equal to distance over time, and therefore time is equal to distance over speed. The distance is 50 meters, the speed is 3,1 meters per second, and I get 16,1 seconds to get across that river. Simultaneously, I've got boy B. he is going to do those 50 meters in 2,95 seconds, and that turns out to be 16,9 seconds. So how much later did he come in? The change in time, remember what the question was? How many seconds after the first swimmer does the second swimmer get in? So the change in time is going to be 16,9 seconds minus 16,1 seconds, and therefore the second swimmer comes in 0,8 seconds later. Next example. Two puppies tug on one slipper. The forces that they exert on the slipper are represented by the following diagram. So I've got 8 newtons off to the right, 6 newtons to the left, 80 degrees from the north line, 50 degrees from the north line in the opposite direction. First it says calculate the horizontal and vertical components of the 6 newton and the 8 newton force. So let's see how we're going to do that. First I'm going to create a triangle. So there's my 6 newton triangle, and this is going to be my 8 newton triangle. Whoopsie, what do I do? Up. This line actually needs to go all the way up there and across. So we've got 8 newtons, much longer line. Then I am going to label them, and I'm going to say, here is my opposite, this is my hypotenuse, and that is my adjacent, opposite, and hypotenuse. First, let's take a look at the 6 newton force, and we have to calculate the horizontal and the vertical components. So for the 6 newton force, the horizontal component, horizontal, is going to be the opposite side. So it's going to be sine of 50 degrees is equal to the horizontal opposite over the hypotenuse 6, and therefore my horizontal turns out to be equal to 4,6 newtons. And remember, it needs a direction west. My vertical for the 6 newton force, vertical component is going to be adjacent, and therefore I'm going to use cos. Cos of 50 degrees is the vertical component of the force divided by the hypotenuse, and therefore my vertical component turns out to be 3,86 newtons, and in this case it is north. It's facing upwards. Taking a look at my 8 newton triangle, my horizontal component is going to be the opposite side, and therefore I am going to say sine of 80 degrees is equal to opposite over hypotenuse, and therefore my horizontal component for the 8 newton is going to be 7,88 newtons, and this is going to be east, it's pointing to the right, and my vertical component is going to be on the adjacent side, so it's cos of 80 degrees is equal to the vertical component divided by 8, the hypotenuse, and I land up with the vertical component of the 8 newton force being 1,39 newtons north. Now, the next thing is I have to use these components that I've calculated to calculate the resultant horizontal and vertical components, and hence the resultant force. So let's start by getting the resultant horizontal. Resultant horizontal component is going to be 4,6 newtons to the west, and I need to subtract, since they're in opposite directions, the 7,88 newtons to the east. I land up with 3,28 newtons, and that is to the east, obviously in favor of the bigger of the two forces. Then if I am looking at the vertical, they are in the same direction, so I am going to add 3,86 and 1,39. They're both going north, So I'm going to land up with an answer of 5,25 newtons north. Now that I have those two, I can draw a vector diagram. I have got 5,25 newtons going to the north. I have got 3,28 newtons going to the east. Complete a parallelogram and determine the resultant. I'm also interested in some sort of an angle. I'm going to choose the angle that would be on a bearing. That's the most convenient angle to use. Looking at my opposite, my adjacent, and my hypotenuse. If I want the hypotenuse, h squared is equal to a squared plus o squared, which is going to be equal to 5,25 squared plus, remember that this opposite side is exactly equal to the horizontal component, so I'm going to put 3,28 squared, and when I square root that, I land up with an answer of 6,19 newtons. I still need the direction. I know my opposite and adjacent, so I'm going to use tan of alpha is equal to my opposite over my adjacent in this triangle, and when I punch that into my calculator, alpha comes out to be 32 degrees, and therefore my resultant is equal to 6,19 newtons at 32 degrees.